So good morning to all of you TyBsc Physics student. We have to see here our subject is the solid state physics, and we want to continue the lecture on the second chapter, which is X-ray diffraction and other characterization techniques. So in this lecture we want to see the next characterization technique, which is considered as scanning electron microscope. This scanning electron microscope characterization technique, which is used for to analysis or understanding the topography and composition of the sample or atom or material. So in this scanning electron microscope system, which is considered as the electron microscope, which is produce the images of sample by scanning it with the focus of beam of the electron. So that means that electron focus beam, that is electron beam, which is incident on a surface of material. And this electron beam which is incident on surface of material, so this is interact with surface of sample or surface of atom or material. So if this electron which is interacting with surface of sample, so this is used to information about given the sample surface topography and composition of a material. And this pattern of electron scanning or scanning electron microscopy, so that beam position which is combined with detected signal to produce the image. And this is scanning electron microscope, which is very high resolution, which is better than the 1 nanometer length. And this is specimen which is observed in two techniques which is available here. First of one which is high vacuum, and second one which is the low vacuum. And this scanning electron microscope mode, which is detected on the secondary electrons. That secondary electron which is considered as wave beam of the electron which is incident on material, and that energy of this beam which is the electron of the material which is knocked out. So this electron considered as the secondary electron. This number of secondary electrons which is depends on the beam incident on material. So what is the angle created from the material whose incident beam, so that depends on the number of secondary electron which is beam meets at the surface of the specimen. And that is on the specimen topography by scanning the sample and collecting the secondary electrons in a special detector, and that image which is producing, so that displaying the topography of the surface which is created. So that is mean by this characterization technique, which is used for to observe the nature of the surface or the upper layer of the surface for the topography or what type of crystal material. So that idea which is given by this microscopic system. This type of electron microscopic or scanning electron microscope, that include the characteristics of which is considered as X-ray, light, secondary electrons, backscattered electrons, transmitted electrons, and specimen current, which is almost all scanning electron microscope have the secondary electron detector. So, and this microscope also used for to facility to detect the single or the signal due to the backscattered electrons, transmitted electrons, which is the according to the requirement. And next point we have to see here, that beam of the electron which is incident from the or which is emitting from the tungsten lamp. So that electron which is incident on the surface of sample, which is it interact with the atoms or near the surface of the material, and this signal resulting from interaction are detected. And this most of the common detection mode secondary electron imaging, that is SEI, and that scanning electron microscope that produce a very high resolution with range considered as 1 to 5 nanometer. And these characteristics, which is three-dimensional appearance, which is useful to studying and understanding the surface structure of a sample. So that clear that here idea. So this microscopic system or scanning electron microscope, which is used for to understanding the structure of the sample or surface structure of the sample. And also the backscattered electron, that beam of the electron which are reflected from the sample by elastic scattering. So this is the analytical scanning electron microscopy with the spectra made from the characteristics of the X-ray. And we have to know that characteristics of X-ray, which is considered as the alpha X-rays, beta X-rays, that have the suitable pattern, which is that X-ray which is incident on the material. And what about the characteristics of this material, which is shown by the X-ray characteristics method? According to the Brack's diffraction condition or formula, we have get clear analyze the idea what type of crystal nature which is there. And this intensity of backscattered electron signal, which is strongly repeated with the atomic number Z. And we have to know that the atomic structure idea. So that atomic structure, which is considered as two part, nuclear part and extra nuclear part. In nuclear part consists of the nucleons, which is considered as the neutrons and mass of these atoms, and extra atomic part, which is considered as the atomic number Z, that how many number of electrons is present there. So that depends on because of whatever incident electron beam which is incident on the surface of this, so directly effect on the shell of the electrons, which is knocked out or excited or whatever possibility is there. So that provide the information about the distribution of different element in the given sample. And when electron energy of the electron beam, if remove that electron from the inner shell of the atom of the sample and characteristics X-ray are emitted, so these characteristics X-ray are used to identify the composition, measure the abundance of the element in the sample. So in this typical type of the scanning electron microscopic beam, that electron beam which is thermically emitted from the electron which is fitted. So that see in this figure, that top of this figure, that electron gun is there, and this electron gun or electron beam which is emitted from the tungsten filament, and this tungsten filament which is normally working of the principle of the thermionic emission. And that thermionic electron guns which have the property of highest melting point and lowest vapor pressure of all the metals, and they are allowing to heat the electron emission. Other also example of this lamp, which is also here, that lanthanum hexaboride cathode of this, but this tungsten lamp as compared to this is the cost which is low. And this electron beam, which is considered as the range, range from 0.2 kilovolt to the 40 kilovolt, and it is focused on one or two condenser lenses of the spot 0.4 nanometer to 5 nanometer of the diameter, which is shown in the figure. So consider in this figure there are the different lenses which is there, so that the below of this electron gun, first condenser lens, second condenser lens, that different condenser lenses which is there for the detector, and after that the deflection coil. So that electron beam which is incident from this or which is emitted from this electron gun, so that pathway which is considered as passing through these lenses, and finally which is incident on the specimen holder, that is considered as the sample is there, and this passing through this, so that X-ray detector is there, objective length is there. So and this process overall which is in created in the vacuum, so that's why vacuum pump also need there. So that if we consider this emitted electron beam which is passes through the pair of the scanning coil or pair of the deflector plates or in the electron column, and typically the final lens and which deflect the beam in the x and y axis. So it scan the raster fashion over the rectangular area of the sample surface. And bottom of this figure, so here the specimen holder, that is sample, so sample is there, and this electron beam which is incident from the tungsten lamp and which is passed through that different types of the lenses, and finally which is incident on this sample. And after incident, so we have to analyze to understanding the study of whatever detecting images. So clear that idea what is the topography or what is the surface crystal structure of this sample. So if we consider first of all the primary electron beam which is interact with the sample, or you have to know that first of all this electron beam which is emitted from the tungsten sample. So first of all consider this energy is high energy before interacting with the surface of the sample, and if this beam which is interact with sample or incident on the sample, so that electron lose energy, this electron beam which is lose energy by repeated random scattering and absorption within the teardrop shaped volume of the specimen known as the interaction volume, and it extends less than 100 nanometer to approximately 5 micrometer of the surface. So that means that the property when the electron beam which is incident on the surface of the sample or the specimen, it loses the energy of the electron, and that size of the interaction volume which is depends on the electron landing energy, and the atomic number of the specimen and specimen density, that the energy which is exchanged between the electron beam and sample which result in the reflection of high energy electrons by the elastic scattering, emission of secondary electrons, and by inelastic scattering and the emission of the electromagnetic radiation, and each of which can be detected by specialized detector, and the beam current absorbed by the specimen can also be detected and used to create the image of distribution of the specimen current. So this is the working principle of this scanning electron microscope, and this if we consider that electronic amplifier of various type are used to amplify the signal. So after that whatever process is electron beam which is emitting from this tungsten lamp and which is incident on the or passing through the different types of the lenses and detectors, so which is incident on this sample and whatever measuring data. So that is we have to use here the electronic amplifier which are used to amplify the signal, and this signal are displayed as the variation in brightness on the computer monitor or vintage model on the cathode ray tube, and each that uses of this computer monitor, each pixel of computer which is video memory is synchronized with the position of the beam of the specimen in the microscope, and that resulting image is therefore the distribution map of the intensity of the signal being emitted from the scan area of the specimen. And if we consider the older microscope, the image may be captured by the photography from high resolution cathode ray tube, but in the modern mechanics image we save as a computer data storage. So next point which is considered here, the application of the scanning electron microscope. This scanning electron microscope which is used for, or the scanning electron microscope is routinely used to generate high resolution images of the shape of the object and show the spatial variation in the chemical composition. So that first use which is considered as acquiring elemental maps or spot chemical analysis. Second which is considered as the discrimination of the phases based on the mean atomic number, that is commonly related to the relative density. And third one which is considered as the compositional map based on the difference in the trace element, activators, and typically transition metal and rare earth element. So this SEM, which is also widely used to identify the phases based on the qualitative chemical analysis and or crystal structure to precise the measurement of very small features of the object, which is down to the 50 nanometer size, and also accomplished the using of the scanning electron microscope. It is also used for the backscattered electron images, that is BSE, can be used for rapid discrimination of the phases of the multiplex sample, equipped with the diffracted backscattered electron detectors, that is EBSD, can be used to examine the microfabric and crystallographic orientation many material. So this is the idea about the scanning electron microscope, and we have to summarize that scanning electron microscope, that electron beam which is emitted from the tungsten lamp by thermionic emission principle and by passing through different lenses which is incident on the material surface, and incident on this material surface whatever images producing which is detected, so which is used to understand to analysis of the topography of the crystal material, composition of the material, and to understanding the surface of the material or a sample, what type of nature it is used for the scanning electron microscopy. Next method which is considered as scanning tunneling electron microscope, that is simply say that the TEM, that is tunneling electron microscope, and this is the new type of the microscope called scanning tunneling microscope, that is STM, which is has been first built by the G. Binning and H. Rohrer in 1983 for the monitoring of the surface structure of the material. Okay, and in this microscope the specimen whose surface is to be looked into is made in the form of the one electrode and a metallic material with the sharp needle which is used to the other electrode. So see, in this method two types of electrode is there, that is see in the figure. So that is one electrode which is considered the one electrode, and other one is the metallic material with sharp needle. So that which is shown in the figure here, so that electron, so that needle tip is there, that is the electrode, and below of this they are the surface of the sample, and whatever which is process is there which is recorded by the computer screen and which show the whatever property is there. So see here, so that consider in this figure the sharp tip of the needle is brought very close towards the surface which is to be scanned. So consider in this figure, so that needle tip which is near to the this surface of a sample, and this scan in such a way that electron clouds of the needle and surface which is gently touched to the other, which is show very clear in the figure, and voltage applied between two electrode. So first of all we have considered there are the two electrode, and this voltage applied between these two electrode which causes the electron to flow through the narrow channel in an electron cloud, and the flow of the electron between two electrodes which is called as the tunneling current. So these two electrodes, so between this current which is flowing, so that is known as the tunneling current, and the density of electron in the electron cloud which is falls exponentially with the distance. Tunneling current is very sensitive, and the distance between the tip of the needle and surface of the specimen which is very close to each other. So see in this figure, and this change in the distance of order of atomic diameter of the single atom which is causes the tunneling current by the factor of the 1000. And next point which is considered has the tip of needle is scanned along the counters of the surface of the specimen. So this is used this needle which is scanned along this surface of the specimen, and as the tip is swept across the surface, that comprise control feedback mechanism senses and tunneling current and maintains the tip of the electrode at constant height above the surface of the atoms, and thus the tip of this follows counters of the surface of the specimen. The motion of the tip of the electrode is read to process by computer and display screen. So this all this method, so which is show in this method, so that tip of needle which is close to the surface of this, and that electrode count, and this needle scan whatever data is there which is recorded on the computer screen, and this three-dimensional image of the surface can be obtained by sweeping the tip through the pattern of the parallel lines separated by a small distance which is shown in this figure. And this instrument which is considered as the scanning tunneling microscope, that is STM, which is used to reveal the surface of the structure of the material. So summary of this scanning tunneling electron microscope system, so that system or that technique which is used for to analysis the material surface or the monitoring the surface structure of the material. And in this system consider that two electrodes is there. First one which is look into the made up in the form of the one electrode, and other one is the metallic material type. This figure show in the material with sharp needle. This is used for the other electrode, and this is very close to the material surface to analyze or detect or scanning the surface of the material, what type of nature, so that have clear that idea. So scanning of this instrument, we have to get clear idea of the surface of the material or topography of the material or structure of the material. So thanking of you, and up to the this lecture so that your second chapter X-ray diffraction and characterization techniques which is end. Now next lecture we want to start the next chapter which is magnetism. So thanking of you.